NENOMATICA, where mathematics meets YouTube excellence. In this video, we will master a powerful tip. When three cubes add to 0 and the bases themselves add to 0, it collapses to a simple product. We'll present the general identity, then the linear form, and finish with clear conclusions. First, let us set up the scene with our example and the problem statements. Then we will verify the zero-sum condition. Verify the zero-sum condition. We confirm that f of x plus g of x plus h of x equals 0. This will unlock the special identity that turns the sum of cubes into 3 times the product. Step 2. Apply the zero-sum cubes identity. The identity says, if a plus b plus c equals 0, then a cubed plus b cubed plus c cubed equals 3abc. Replacing a, b, c with f of x, g of x, h of x, we get 3f of xg of xh of x equals 0. Notice the change part. The left side was 3 cubes. Now it is a product. Step 3. Use the zero product property. If a product is 0, then at least one factor is 0. Therefore, f of x equals 0 or g of x equals 0 or h of x equals 0. These are the solution branches. Now, let us apply the same logic to the linear case and extract explicit x values. We will set up the example again and repeat the 3 steps. Play button step 1. Verify the zero-sum of the bases. This enables the same identity we used before. Play button step 2. Apply zero-sum 1. Verify the zero-sum of the bases. This enables the same identity we used before. Verify the zero-sum of the bases. This enables the same identity we used before. Apply zero-sum cubes identity. Now, the sum of cubes becomes 3 times the product of the bases. Play button step 3. Apply the zero product rule. Each factor can be 0, giving 3 candidate roots. Solve x plus b equals 0, cx plus d equals 0, and x plus f equals 0. Let us summarize what we learned and encourage practice. Final takeaways. For the general form, f of x equals 0 or g of x equals 0 or h of x equals 0. For the linear form, let's solve this equation step by step. We are given the sum of 3 cubes equals 0. The expression is open parenthesis 5x minus 7 close parenthesis cubed plus open parenthesis for minus 3x close parenthesis cubed plus open parenthesis 3 minus 2x close parenthesis cubed equals 0. Step 1. Check the sum of the linear pieces. Consider a equals 5x minus 7, b equals 4 minus 3x, and c equals 3 minus 2x. Add them together. 5x minus 7 plus 4 minus 3x plus 3 minus 2x. Now group x terms and constants. Let's show this identity and apply it. Step 3. Apply the identity to our equation. The left side, a cubed plus b cubed plus c cubed, becomes 3abc. Therefore, 3 times, open parenthesis, 5x minus 7, close parenthesis, times, open parenthesis for minus 3x, close parenthesis, times, open parenthesis, 3 minus 2x, close parenthesis, equals 0. Step 4. Solve each linear factor equals 0. 5x minus 7 equals 0 gives x equals 7/5. For minus 3x equals 0 gives x equals 4/3. 3 minus 2x equals 0 gives x equals 3/2. Therefore, the solutions are x equals 7/5, x equals 4/3, and x equals 3/2. Great job using structure to avoid expanding cubes. We are going to solve this equation using a powerful identity for sums of cubes. The problem is, open parenthesis 1 minus x close parenthesis cubed plus, open parenthesis 2x plus 4, close parenthesis cubed minus, open parenthesis, x plus 5, close parenthesis cubed equals 0. We'll rewrite it, check a special condition, and then factor it to find all solutions. Next, we move the negative sign inside the cube of the last term. The rule is negative, open parenthesis, x plus 5, close parenthesis, cubed, equals, open parenthesis, negative x minus 5, close parenthesis, cubed. So the equation becomes open parenthesis 1 minus x close parenthesis cubed plus open parenthesis 2x plus 4 close parenthesis cubed plus open parenthesis negative x minus 5 close parenthesis cubed equals 0. Here is the key identity. When a plus b plus c equals 0, A cubed plus b cubed plus c cubed equals 3abc. Let's check the sum of plus b plus c using it equals 1 minus x, b equals 2x plus 4, and c equals negative x minus 5. 1 minus x plus 2x plus 4 plus negative x minus 5 simplifies to 0. Since the sum is 0, we can apply the identity. Therefore, the left side becomes 3 times open parenthesis, 1 minus x, close parenthesis, open parenthesis, 2x plus 4, close parenthesis, open parenthesis, negative x minus 5, close parenthesis. Now, we have a product equal to 0. 3abc equals 0 implies abc equals 0. That means at least one factor is 0. So we set each factor equal to 0 and solve. Solve each factor. 1 minus x equals 0 gives x equals 1. 2x plus 4 equals 0 gives x equals negative 2. Negative x minus 5 equals 0 gives x equals negative 5. So the solutions are x equals 1, negative 2, and negative 5. Quick challenge. Can you verify each value in the original equation? Pause and substitute x equals 1, negative 2, and negative 5 back into the original expression to confirm it equals 0 each time. Welcome! In this example, we will solve a cubic-style equation by turning it into a sum of 3 cubes and using a powerful identity. First, we show the example label, then the problem in bold orange math. Step 1. Rewrite the constant 8 as 2 cubed. Now show the step title. Then we rewrite the right-hand side as 2 cubed times 2 minus x, all cubed, which is the same as the cube of 2 times 2 minus x. Step 2. Bring all cubes to one side to form a sum of 3 cubes equal to 0. Now, the step title. We subtract the cube of 4 minus 2x to the left side and set the expression equal to 0. Then we may rewrite minus 4 plus 2x as the third cube to emphasize a sum of 3 cubes. Step 3. Apply the identity for the sum of 3 cubes when the 3 bases add to 0. Now, the step title. First we check that the 3 bases do add to 0. Since the sum is 0, the sum of cubes simplifies to 3 times the product of the 3 bases. Step 4. Use the zero product property. Now, the step title. Set each factor equal to 0 and solve for x. Great work! The solutions are x equals negative 1/3, x equals 3/5, and x equals 2. Quick challenge. Substitute each solution into the original equation to verify it holds true. Take a moment to check. We will solve a cubic-style equation by transforming it into a sum of cubes and then factor it cleanly. Here is the problem we will solve using the exact algorithm shown. Transform to cubes, verify the special condition, factor, and solve. Step 1. Rewrite the constant 27 as 3 cubed. Then rewrite negative 27 times the cube of x minus 2 as negative 3 cubed times the cube of x minus 2. Step 2. Write each term explicitly as a cube. Negative 3 cubed times x minus 2 cubed can be grouped as the cube of negative 3 times x minus 2. And the negative of 3 minus x cubed is the cube of negative of 3 minus x. Step 3. Simplify the linear expressions inside each cube. Negative 3 times x minus 2 becomes 6 minus 3x, and the negative of 3 minus x becomes x minus 3. Step 4. Check that a plus b plus c equals 0, whereas 2x minus 3, b is 6 minus 3x, and c is x minus 3. The sum is 0, so we can use the identity. A cubed plus b cubed plus c cubed equals 3abc. Step 5. Set each factor to 0 using the zero product property. Solve each linear factor to get all solutions. Therefore, the solutions are x equals 3/2, x equals 2, and x equals 3. Thank you for watching. Don't forget to like, subscribe, and hit the bell icon for more math lessons. NENOMATICA, where mathematics meets YouTube excellence.